Hello and welcome back to another lecture from Organic Chemistry. In this chapter, we're going to go through aldehydes and ketones. And we will start with nomenclature of both functional groups. And after that one, we will try to practice some common chemical reactions for both functional groups. So first thing that we need to know, how to identify or differentiate aldehyde from ketone. Aldehyde technically is similar to ketone, is a functional group that it has a carbonyl group. And so in both cases, we have a carbonyl, and one of them, the carbonyl group, is terminal. That means attached to only one substituent, and the second substituent, it will be hydrogen. So if you have terminal carbonyl group, that's an aldehyde. But in case of ketone, the carbonyl will be trapped between two substituents. The most common aldehyde in ketones, I can name formaldehyde, that we use it to preserve, like foods or fruits. And the second one, it will be the acetone, which is a ketone, and is one of the most common solvent in organic chemistry and also in industry. Maybe one common actual usage of it is like whenever you want to get rid of a paint, you can easily drop a small amount of acetone and dissolve that in the paint and get a fresh surface. In bio, we have both functional groups. And for example, when you smell vanilla, that means you are dealing with an aldehyde functional group. Or like in case of cinnamon, again, it's aldehyde, but the mint, it has a ketone group. And if you take in like an almond and you snap that one, the intense smell that you get, that's a smell of aldehyde functional groups. Do we have those molecules also in our body? Of course, we have them, and some of them, they work as actually signaling hormones. How do I name aldehyde and ketones? And the pattern is going to be the same for both of them, and the only difference between them, at the end of the name, it will be a bit different. And let's start with this. The first thing that we need to know, the biggest actually changes, or the parent change. So let's find that one. Next thing is we're going to highlight any substituent that's attached to it. Then we will give it a position or look at or a number. And at the end, we will order them alphabetically. And in case of aldehyde, remember this. We're going to take an alkyne, for example, name, and we will replace the E by Al to turn it technically to aldehyde. But for ketone, again, we have an alkane. We take the E and we replace it by O and E, or we can say 1. Okay, let's practice some example. So first thing that we need to identify the longest chain, or the parent one. The parent chain is going to be the chain that it has the functional group, and in this case, it will be the carbonyl group. So I'm going to say the one on the right side, it has a functional group. So I'm going to start labeling from here. I will call this one 1, and then I say 2, 3, 4, 5, 6. So I have 6 carbon. It will be a heg, supposed to be hexane. But because we have a carbonyl group, I'm going to replace that one by Al. So it will be hexanol. Okay, so we replace the E by Al. And how about the ketone? The ketone is going to be the same thing. Okay, the only difference, like at the end, the name, like we take the E, replace it by O and E. Otherwise, the order, the way we label them, it will be exactly the same. We have a molecule that it has 3 functional groups, and I want to know like from which side I need to start labeling it. A priority in this case is going to go to the carbonyl. Give the carbonyl the smallest possible number. Okay, listen carefully. Give the carbonyl the smallest possible number. So I'm going to start labeling it from the left side, and that means like the carbonyl is going to get number 1, and then OH it will get number 5, and alkene it will be 6. Okay, and now when it comes to carbonyl and OH or alkene, the priority goes to the carbonyl, and that means that you're going to treat the OH or the alcohol actual functional groups and also the alkene as substituent. Okay, listen carefully. You will treat them as substituent, and the carbonyl, it will be the main functional group. I want to practice some example, and so I start with aldehyde. I have a molecule it has chloride and phenyl I'm going to say this is going to be my main chain. It has 3 carbons, and let's start labeling it. I go 1, 2, 3. Okay, what do we have? We have a chloro, and we have a phenyl group attached to the main chain. Now, this one will be aldehyde because it has hydrogen attached to the carbonyl group. Okay, so the way I'm going to name it, until now, I have this. I have a propane because I have 3 carbons. And we said we're going to take the E, we replace it by Al to say this is aldehyde. Next, I need to show position of each substituent. I have a chloro and phenyl. Chloro will get a priority, and the chloro is sitting on the second carbon. I say 2 chloro, and then 3 phenyl, and then I say pro. Okay, we're supposed to say propane. I'm gonna get rid of the E and replace it by Al. Now, I do have a chiral center, and it's the second carbon. It has a chloride attached to it. The chloride is back up the plane. That means hydrogen is facing to us. That's going to be hydrogen. Now let's start, figuring the configuration. Chlorine, it will be number 1. This one will be number 2, and that one it will be number 3. So this is counterclockwise. Hydrogen is facing to us. So I'm going to say it's supposed to be S because hydrogen is facing to us. We will flip it to R. And I have only one functional group, one chiral center. So I'm going to say here, I will open parentheses and I will write R. There is no need to write any number in the front of it because we have only one functional group, one chiral center, and is the one that I put star on it. Okay, so it will be R2 chloro 3 phenyl propanol. Okay, next one is we have a cyclohexane is attached to carbonyl group, and if that's the case, the way you are supposed to name it, just simply use carbaldehyde, and after naming, the naming actually the ring. The ring is cyclohexane, so I go. This is a cyclohexane. Okay, now I do have a functional group attached to it, and this is the functional group is a aldehyde. And so I'm going to say it will be cyclohexane carbaldehyde. And that's going to be the correct name for it. And okay, later you will see that whenever I name a compound like this, I can actually come with different names instead of one. We can actually write it 2 or 3 different ways. Okay. Now, there are some basic molecules, basic aldehyde or ketone molecules that, we adopted actually the name for them, and they say we are just simply using them, and in the IOPAC adopted that, those common names, and there is no really need or force to stick with the, the IOPAC, system. And one of them is the formaldehyde, and the second one, it will be acetaldehyde, and then last one, it will be the benzaldehyde. And so in this case, I have only one carbon, and that's a carbon. So I'm supposed to say is methane. Okay, let's say is methane. And we're going to replace the E by Al. So this one, it will turn to methanol. Okay, next one is ethyl. Okay, or I should say ethane. So this one is ethane. We're going to replace the E by Al. It will be ethanol. And the last one, okay, as you see, the name, it says benzaldehyde, but I can say I do have a methyl there, a phenyl group attached to it. So how about this? Can I say this is a phenyl? Okay. And then I have methane, okay. And I'm going to replace the E at the end by a L. So it will be phenyl methanol. And again, I'm telling you, there are more than one way to actually name this chemical compounds. And the second you start actually adding some carbon or increased number of carbon with the main chain or the parent chain, names will be actually more. The number of names will be more than one. Let's keep practicing. We said the priority goes with carbonyl group, regardless of whether we have OH, chloride, or alkene functional groups. So in this case, because I have aldehyde, I'm going to say this is number 1, and then I go 2, 3, 4, 5, 6, and 7. Okay, so I'm dealing with heptane. Okay, Next, there is a functional group, is aldehyde. So it's supposed to be heptanol. Okay, we have OH, and also we have a methyl. Okay, let's write the full name for it. And I'm going to treat the OH as hydroxy substituent, and this one, it will be just simply methyl. So I'm going to say the priority goes with the hydroxy, and I go 5 hydroxy. And then on the, again, same carbon, I have a methyl group, so it will be 5 methyl. And I have 7 carbons, so I will say this. It will be heptane, supposed to be heptane. I will replace the E by Al, so it will be heptanol. Okay. Next one, I changed the structure a bit, and I added another functional group, but this time I added alkene, and I want to know how to name it. Priority, again, it goes with the carbonyl. It will be 1, 2, 3, 4, 5, 6. Now, question is like, should I call this one 7 or like the CH2? Remember, we said when it comes to alkene or alkyne, when we label them, we have to pass the double or triple bond. So the correct way to label it is to put the 7 on the other side of the double bond. And I did not start the labeling from here, and because I said this one gets the highest priority, so you have to give it number 1. And again, we have this. We have 7 carbon, supposed to be heptane. Okay, I do have a double bond. So how about this? We're going to replace the E by the A by E, and then we're going to turn it to heptene. Okay, heptene. And if we want to turn it to aldehyde, last E at the end, we're going to turn it to Al. So it will be heptanol. Okay, let's go after it. I have a hydroxy group, so I go 5 hydroxy. Next, I have 2 methyl groups. Where are they? 1 and 5, and the second one 6. So I go 5 and 6 dimethyl. Okay, and now I'm supposed to say is the heptene, and also add the Al at the end of the name. But I need to say position of the double bond. So I have 7 carbon hept, and then I need to say where the double bond is. Double bond is sitting between 6 and 7. So I go 6 En. That's showing position of the double bond. And at the end, I'm going to say 1 Al. 1 Al. Okay, this is aldehyde. And the only way to get an aldehyde is to have the functional group of the carbonyl on the first carbon. Do I need to say this one? Okay, do I need to say that one? If it's an aldehyde, we know the carbonyl group always is going to be at the beginning. So I'm going to rewrite it. Let me copy paste this one. Okay, I'm going to get rid of, technically, I'm going to get rid of this one. And I will just simply add the Al to the end of En. Okay, why I'm doing it? Because it's aldehyde, and aldehyde, the carbonyl group, always going to be at the beginning of the molecule. So why do you want to say 1 and Al? And because you already know that it's going to be the first carbon. So it will be 5 hydroxy, 5 and 6 dimethyl hept. And then we need to say position of the double bond, 6 En, and we will add Al at the end because we are supposed to say 6 E-N-E. And we took the last E, we replaced it by Al to say that we are dealing with aldehyde. And this is going to be the end of this lecture, and thank you very much.